The learning targets for this lesson are: I can state whether an image has symmetry, I can explain what a reflection is, and I can reflect a figure over the given line. So first definition we're going to look at is the line of symmetry. It's where you can fold the shape to form two mirror images of each other. So I'd like you to look at these examples and tell whether the dotted line on each shape represents a line of symmetry, right? Yes or no. So if I was to look at A and I folded the figure on this line, would I get a mirror image? Would they land on top of each other? Would the two sides land on top of each other? The answer is yes, it is a line of symmetry. If I looked at B and I wanted to fold on this dotted line, would the two sides land on top of each other? The answer is yes. If I looked at C and I folded on this diagonal line, would these two pieces land on top of each other? The answer is no, it is not a line of symmetry. And D, if I folded on this dotted line, would these two pieces land on top of each other? No, so that is not a line of symmetry. So we're going to continue with our unit of transformations, which are changes. The first one we did was dilation, where an object became bigger or smaller and produced similar images. And now we're going to look at a reflection, okay? We still have two more after this. So when I think of reflection, I think of looking in a mirror, and that's exactly what a reflection is, a mirror image. Here are some more pictures of a reflection. Okay, we have some horizontal lines where they see it underneath them, or we have some vertical lines of symmetry where it's across or next to them. These are all examples of reflections. So reflection, if you look at the word, highlights an FL. So the FL reminds me that a reflection is a figure that is flipped over a line. So if you flip the entire image or the figure at the line of symmetry, it should rest on top of the other figure. So a reflection is a flip. They are congruent because both figures are the same size and the same shape. If I take something and I flip it, it's going to stay the same size and the same shape. So here's some examples of reflections. This triangle is being reflected over a vertical line of reflection, which we usually call the y-axis. And this triangle is being reflected over a horizontal line of reflection, which we call the x-axis. So this is the most important thing that you're going to learn, okay? Each point and its image are the same distance away from the line of reflection. So that's represented here. If I have a red point a certain distance away from that line of reflection, the other red point is going to be the exact same distance away. Green is a certain number of distances away, and green on the other side is going to be that same distance away. So these dotted lines are representing the same distance away from that line of reflection. So let's look at some examples. I'd like to look at triangles A, B, C, and D. And I'd like to know which two triangles are reflections of each other across the x-axis. So this is my x-axis, and I want to know which two are flipped over this x-axis. So if I take A, could I flip it over on C, or could I take B and flip it over on D? The answer is take A and flip it over on C. It absolutely could have been C and reflect it and flip it over on A. We don't know which one was the original or image because they are not labeled. Okay, the next question I'd like to look at is for which two triangles is the line of reflection the y-axis? So if I draw a line on the y-axis, and that's my line of symmetry, which two triangles would be flipped over on top of each other? Would A flip over on B, or would C flip over on D? The answer is C is flipped over on D. Okay, we are going to look at now labeling, since we know that labeling is the most important, so we can figure out which one was the original and which one is the image. So this figure, the original figure, is flipped over the x-axis. It's reflected over the x-axis. We're just going to label the image. It's already plotted for us. So we see that C is 3 points away. So on that same line down, C prime is going to be 3 points away. Okay, B is 3 points away from the x-axis, so B prime is going to be 3 points away from the x-axis. okay? A is 9 points away from the x-axis, so A prime will be 9 points away from the x-axis. So there is our flip and our reflection. If I was to look at this triangle, this original, and I want to produce this image over here and I want to flip it or reflect it, my only job is to count. If B is 2 points away, then B prime will be 2 points away. Okay? If C is 6 points away, 6 prime will be 6 points away. Okay? And if A is 4 points away, A prime will be 4 points away. And there we then have our flip or our reflection over the y-axis. Okay, this gets to be a little bit trickier because this figure is reflected over the y equals 1 line. Okay, so that means I go to my y-axis and I find the 1. Okay, this is the line that we're going to reflect over. Okay, and we'll talk more about that in a couple minutes. So how do I know that it's reflected over that line? Because C would be 5 boxes away from that line, and C prime would be 5 boxes away from that line. If I wanted to count D, I would count 7 boxes down, so 7 boxes more is going to be D prime. A is 9 points away, so A prime will be 9 points away from that line. And lastly, if I look at B, it will be 7 boxes down, so 7 boxes down again is B prime. So if I took this figure and I flipped it over that line, that would be my reflection. Last figure we're going to label is reflected over the x equals -1 line. So I go to my x-axis and I put a point at the -1 and I draw myself a line. Okay, we're just going to count and reflect over this line. So D is 3 boxes away. So if I count 3 more, that's where D prime would land. A is 8 boxes over, so A prime again would be 8 boxes over. C is from this line 3 boxes over, so 3 more would be C prime. And B is 8 boxes over from this line, so 8 more would be B prime. Again, that's a flip. I'm flipping it over that line, and that's my reflection. So quick question are, what are the properties of reflections? You could take a minute and try to answer that. I'm going to tell you that the size and the shape stay the same, so they are congruent figures, but the orientation changes, which means the way that it's facing changes. So now we're going to have to draw and name the line of symmetry. So I see this figure was flipped, and it was flipped down here. So I'm going to guess that it's the x-axis. Okay, we do have to count to make sure that that's accurate. If I look at point D, it's 3 boxes away. Point D prime is 3 boxes away, so that seems to work. Let's check A. A is 5 boxes away. A prime is 5 boxes away from that line, so that seems to work. We'll check one more. B is 7 boxes away, and B prime is 7 boxes away. So x-axis is our line of symmetry where the figure was flipped. Okay, if I look at here, I have my original triangle, which crosses the y-axis, but that's okay. I'm still going to look at each point, and we have to try to find the line of symmetry. Okay, so I'm going to guess that it's the y-axis. It looks like it was flipped over there. So let's count. From the y-axis, A is 5 boxes away. A prime is 5 boxes away. B is 5 boxes away. B prime is 5 boxes away. And even though it seems different, let's see, C is 2 boxes this way, and C prime is 2 boxes that way. So that still works for the y-axis being my line of symmetry. Okay, one more. We're going to draw and name the line of symmetry. I take this original figure, which is down here. I'm going to flip it up this way, and it kind of looks like the x-axis is my line of symmetry, so we're going to count to make sure. If B is 5 boxes away, I now see that B prime is 3 boxes away. So that cannot work as my line of symmetry. So we're going to move our line of symmetry. Let's take it and we'll move it down a little bit. And let's count now. B is 4 boxes away. B prime is 4 boxes away. C, the point down here, is 9 boxes away. And C prime is 9 boxes away. So that blue line is my line of symmetry, which is now on the -1. So we know something is equal to -1. Okay, and it's on my y-axis, so it's the y equals -1 line. For the last page, I'd like to reiterate that a reflection is a transformation that flips across a line. That line that it flips over is called the line of reflection, and each point and its image are the same distance away from the line of reflection. So I'd like you to take a minute and draw this triangle on your graph paper. First thing is to reflect it over the x-axis, so it's going to land down here in quadrant 4. Count every point the same distance away. Then I'd like you to take your original triangle and reflect it over the y-axis, so it will land in quadrant 2. And again, you're going to count every point the same distance away and label it A double prime, B double prime, C double prime. Okay? You can flip to the next page for the answers. Here are my answers. Okay, if I look and it was reflected over the x-axis, C is 2 boxes away, C prime is 2 boxes away. A is 5 boxes away, A prime is 5 boxes away. So that's a reflection over the x-axis. And if I count to the y-axis, A is 2 boxes away, A double prime is 2 boxes away. B is 6 boxes away, B double prime is 6 boxes away. So that is my reflection over the y-axis. Labeling, again, is the most important, so we know which one was the original and which images were reflected over which axis.